Okay, there we go. Hello, everybody. Welcome, Marty Tron. No, not Rip. So I wanted to do a quick thing where I'm going to look at some science. I got a new CPU, the new AMD 5800X 3D. It's very fancy. Um, so it's going to be a drop-in replacement for the 5600X that I've been running. So the 5800X3D is the new chip from AMD. It's supposed to have a little bit more performance headroom for games. But I want to know if, like, specifically for how I use virtual reality and iRacing, whether it's going to make a difference. I don't care about performance benchmarks from, Passmark or Cinebench or anything like that. I want to know if it's really going to make a difference for me. So I wanted to log out a bunch of parameters that we get in iRacing. David Tucker put in the ability to put out the frame rate, the CPU background, the CPU foreground, and the GPU utilization. And so I wrote a simple program that just grabs those values, writes them to a comma separated file, and makes it so that you can load it up into um, sheets or Excel or whatever you want to visualize it. So I did some runs last night just to cut to the chase and like show what we're actually doing here. And then I'm going to go through the process of like how I've been doing it just to, put it out there. So this is the performance that I enjoy on a regular basis. My headset makes 75 frames all the time. Razor flat performance. And that's what, for virtual reality, that's what you want. You want rock steady performance, no fluctuation in frame rate. But for this kind of utilization, it's a little bit boring. If I turn on HMD, I'm sorry, if I turn on HDR, then I'm a little closer to the threshold, and my frame rate does fluctuate a little bit, and it's a little bit right on the edge. So there's been some speculation in the forums and stuff like that about the SPS feature for single pass stereo and whether it really makes a difference or not. And using this tool, I can say it makes a difference. So this is running the resolution and everything at 75 hertz, HDR on, and SPS off. And you can see there's a lot more fluctuation. Here it's nice and rock steady with SPS on, except for a little bit of variation. But if we turn SPS off, there's a lot more fluctuation throughout the run. If I push my system to, the easy limit that I can just change with a couple settings, that's running 90 hertz, HDR on, and SPS off. So that's what we see here. I'm not making 90 hertz by any stretch at any point. So as far as like giving the headset headroom to not make frame rate and see what the performance is, I think this is going to be one of the benchmarks that's going to help, benchmark the new CPU. And it's interesting. So in this situation, these are the averages over on these columns of these values. So the average frame rate in this run is 74.6. If I'm running at 75 hertz, it is being clamped a little bit, but it's interesting. My frame rate for the average is actually pretty similar, between those two configurations. So setting the headset to run at 90 hertz gives it more performance headroom to fall short, I guess. But in any event, that's what the end result of my project has shown me with the system I've got now. The goal is going to be to upgrade the CPU, run similar settings, or run similar experiments, and see how it works. So what I did was wrote a little C# program, and I've put it here in GitHub for the first time. It's my first GitHub public repository. And I'm going to live here on stream. I'm going to download it and see if it works the way I expect for somebody else. So this is the page for the repository. If you go over here and click on code, you can copy the link to clone the repository. And then if we go run Visual Studio, We're going to tell it we want to clone a repository, paste in the value, and cross our fingers and clone it. Okay, so this is what we get. No, it only works for iRacing, Marty Tron. It's directly getting the values from the iRacing SDK, so it's just iRacing. So if we open up the solution for the iRacing data logger, and that's part of my motivation is I don't care what general performance is. I just want to know the way I run VR in iRacing, whether there's appreciable differences and stuff. And even beyond just the CPU, it really has been helpful so far to verify that SPS makes a difference. Period. It's funny if you look in the forums and stuff, there is a good bit of speculation and superstition that goes on as far as, oh, if I turn SPS off, my colors are more vibrant and my the sweet spot in my headset is better. I don't believe that, and I don't want to get into a religious argument, but SPS, the pixels you get are the same. It's just the cost of how they're rendered that makes a difference. So anyway, we've loaded in the project. We've opened the solution. Let's try building it and see if it falls over. Okay. Okay. I'll fix the source code later. Let's just run the program the way I've got it. So in the repos, luckily I built this last night. Hopefully the build attempt this morning didn't overwrite the binaries. Let's go take a look. So here it is. And there it went. Okay, so that's fine. My use case is to use a replay from iRacing so that we're seeing consistent simulation behavior every time, and then either changing settings or changing hardware. You'll see those as opposed to it ran differently this time. So if we go into my replays, and the one I was using last night was this LMP2 race at Laguna Seca. So the headset's down here on the floor. And if I center the HMD every time so that it's always looking at the same location, that should give us a consistent reference frame. So what I've been doing is switching to the race start. So this is the beginning of the race. We now load up the data logger. It starts to spit out the values. Then I can go back to iRacing, run the lap. So by using a consistent start time and a consistent end time, I'm able to get the same segment of data each run. So, we're not comparing apples to oranges, ideally. And doing it this way, letting it run for a few samples and stuff before even starting the replay, I can trim out those entries. And then also when we stop it at the end, letting it run for a little bit, I can trim off those. So the goal is to have each collection as consistent as possible. Okay, so actually this is going to be really boring because it's just going to be the flat line. You can see down here in the Steam VR that we are making frame rate the entire time. So that's just going to be a flat line. We collected data. Every time through, it saves it as this. Right now, in this version of the program, is just called ASDF.CSV. But it is serious. We go in here and say we want a file, import, upload, drag in the ASDF CSV file that we just made, create a new spreadsheet, import the data. Well, it's system frame rate, CPU foreground, CPU background, and GPU are the values that we can get from iRacing. So in this case, and what I've been doing is I want to start, in this particular replay, it's a little bit arbitrary, but when we're sitting in the grid or before we actually start the replay, it's always the 214th second. So if I trim out those entries first, those rows, so we always start at the 215th second. My sampling is only happening 4 frames per second, so it's pretty slow as far as things go. And part of my goal there is to not do anything that's going to have the monitoring, affect the actual performance. And then if we scroll down here to the end, you can see how we've got a bunch of these 284 seconds. So that's when I paused the replay at the end. And I did accidentally start it again, so we got a few more up to 285. But if we trim those out, we've now got the run just for that first lap segment. And just, because it's the common thing, people care about the average frame rate and stuff. So we can just calculate that. So if we average frame rate, in this particular run, I was hitting 74.9. Like I said, this one's going to be boring. It's just going to be a razor sharp flat performance. But we can look at the other values. These are the averages of the other CPU and GPU values. And then this is the cool part. You grab the columns you want, so starting with the frame number, and then tell the spreadsheet to make a chart. This isn't very interesting. But all we need to do really is change it so it uses the frame number for the x-axis, and then we remove the frame number from the samples, and this is what we get. So, like I said, this was boring. My performance is consistent across the board. There's a couple little hiccups every now and then, but for the most part, it is pretty darn flat. I've got headroom. I can run any of the series that I like and enjoy consistent performance. But if we change it, So for example, we turn HDR on and turn SPS off. Sadly, that is going to require a restart of the simulation, but Laguna Seca loads quick. Load that back up. But yeah, Schultes, this is getting ready for CPU benchmarking. I got the new 5800X. My plan is to put it in the computer. But before I do that, I wanted to get some baseline, data profiling with various combinations of which frame rate I'm having the headset run at, whether it has HDR enabled, whether it has SPS enabled, and see the performance variations there. So while this is loading up, I can just review the actual output that we're looking at is like this. So these are runs that I made yesterday. This is the flatline performance that we enjoy all the time. If we turn on HDR but leave SPS enabled, I still get pretty consistently flat frame rate, but there's a little bit more variation, and especially here the race start where the cars are close together, you can see how there's more variation. And then the run we're about to do right now, this is exciting. The run we're about to do right now will show with SPS off and HDR on at the same 75 hertz frame rate. So let's go to the same beginning of the race. Reset the HMD view so it's consistent. Go run the data tracker. Data logger. Starting back up. And like I said, it's always collecting seconds at 214 for the first few samples. So that makes it easy to trim the data. And away it goes. So it's interesting. I wanted to make it as objective, scientific observation as possible, rather than just, oh, it feels like it's better in these situations or this or that's different. There is some variation, running the exact same lap from the replay without changing the settings. There is some fluctuation and variation. And I don't think I can really get away from that. It's just the way, iRacing might not be exactly the same every time it's going through, or the computer might be thinking about whether it needs to do an update or other stuff going on in the background. But that's happening when I'm racing too. So, this is as close to real world performance benchmarking as I think I can reasonably achieve with what we've got. Okay, so last time I stopped it early, like right around here. We'll go a little further so we can make sure we trim the data. So the logger's still going. Tell it to stop. So now it always writes out the same file. And this was 75 hertz, HDR, SPS off. So it's slightly different naming than I've used before, so I won't overwrite the file or anything. So I did nothing to mitigate the background processes. I've done nothing more than I normally do, and that's part of my goal also, is to, show what's happening as it is when I'm really racing. But do you have specific suggestions as far as what I could do to minimize the background processes? I'm not running much at all compared to what I'm normally running for the game. So I'm not running voice attack, I'm not running OBS, I'm not running all the Kutu apps or those kinds of things. But let's take a look. We go back to the sheets, do another file import. Upload. So now we're going to drag in the new file that we just created. So it's amazing any of this ever works at all. But we'll do the same things really quick. Trim out the 214 records from the beginning. Past 284 at the end. Yeah. Demos are fun. So there we go. All right. Let's take a look at the average frame rate again. I was hoping to see a difference, so that was sort of a red flag that it wasn't the data I thought. Okay, so look at that, 73 average frames per second, running with SPS off. This time, if we grab the samples, make a chart, set the x-axis, remove the frame numbers. Boom. Okay. So, running just the way I normally do, totally flatline performance, turning HDR on and getting SPS off, a lot more fluctuation. So, just make these a little bit more consistent. I guess the units are already the same. So one thing I'm not really clear on at all is what the CPU background value is really supposed to indicate. You know, in this run, that's 5.1. And in this run, it's 5.8. So it's higher, but just a little bit. I don't know. And it's weird because it stays razor sharp in pretty much, or razor flat in pretty much all of the performance measurements I've done so far. Whereas the CPU foreground changes much more significantly. So yeah, I mean, what I've seen so far is absolutely without a doubt, if you are close to not making frame rate, SPS helps. Period. There's no debate. Um, and if I run the headset at 90 hertz, that gives it threshold where it's not making that frame rate, but it's not falling back to like the time warp stuff where it's locking into other frame rates. So I think that'll be the best for profiling. And yeah, a little awkward that the GitHub repository and stuff didn't build straight out of the box, but I'll go fix that and make sure that it's accessible. And my alarm went off telling me that I got to go pick up my mom and do some chores and stuff like that. So anyway, I just wanted to make this quick video to show where I'm going with this. The plan is to do the CPU swap this weekend and see whether we actually achieve any performance increase. So anyway, thanks for watching. Take it easy. Drive safe. I'll see you later. Bye-bye. Pit Girl end stream.